So to find the slant asymptotes, we have to have the numerator degree is equal to the denominator degree plus 1. And then the slant asymptote will come from synthetic division. And I always think about the S in slant, S in synthetic. And it will come again from the quotient that we have in synthetic. And we'll talk about why that is a little bit at the end of this video. So our f of x function here, as an example, is x squared plus 1 over x minus 1. So the first observation is that we do have a slant asymptote because of the fact that if you look at the numerator degree, that is 2, and that numerator degree is equal to the denominator degree of 1 plus 1. So it will have a slant asymptote. So to set up our synthetic division, we take the opposite sign of what is in the denominator. So we see a -1, so we write down a +1. And then we list out our coefficients. Now, be careful here because you do need all the coefficients from the highest power all the way down to the constant. So that would be x squared, x to the first, and then our constant. So in this particular case, we have a coefficient of 1 on the x squared, but we are missing this x to the first power in the numerator. So we will put a placeholder 0, and then our constant is 1. So using synthetic division, we bring down the 1, and then we multiply diagonally. So again, in the multiplication sign, we have diagonal, so we multiply diagonally. So we take 1 times 1, and that of course gives us 1, and we put that in our second row. Now, our next step is that we add vertically. So in the addition sign, we have a vertical, so we will add 0 plus 1, and that will give us 1. We then multiply and repeat this process. So 1 times 1 gives us 1, and then we add vertically to get 2. So to understand what this all means is our x squared is now going to be 1 less. So it's always 1 less of that power. So I started with an x squared, so this will now be an x plus the x to the 0, the constant, and then this last number here is our remainder. And as our remainder, we will put this over the current divisor that we have, the x minus 1. So this will be over x minus 1. Now, the idea of an asymptote is that as you get a very, very large number, there will be this flattening out of the graph. So the issue is that as x goes to infinity, if you think about plugging infinity minus 1 into this remainder, what you're going to see, and again, if you just put in like 1,000,000 or something like that, you'll see that this is going to give you a very small number, and it is going to go to 0. So what will actually matter at the end of the day isn't this remainder. What will matter, the flattening out that we'll see, will be given by this slant line, this equation, which is our quotient. So we'll have y is equal to x plus 1, and that is our slant asymptote. So in order to find the slant asymptote, we perform our synthetic division, and then whatever our quotient is, that quotient will be our slant asymptote.